Okay, let's take a look at this problem. We got our demand function, P, which is price, 500 minus 4x. And we got x is equal to 40. And they say find the price elasticity of demand for the demand function at the indicated x value. Is the demand elastic, inelastic, or of unit elasticity at the indicated x value? Now, I'm going to find the intervals too, just to show a complete process on it. Eta, and I don't draw it worth anything, so this is what it should look like. Looks like a weird n. That's going to equal to p divided by x all over p prime. We got the p, we got the x, we just need p prime. Well, the derivative of 500 minus 4x is negative 4. So eta is going to be 500 minus 4x over x all over negative 4. Now, whenever you have a single fraction over another denominator, you can take that denominator and put it down with this one. So this becomes 500 minus 4x over negative 4x. Okay, and that's eta. Then we want to take the absolute value of that, 500 minus 4x over negative 4x, and set it equal to 1. Where I'm getting that from is, see how this is the absolute value of eta and 1 on this side. So that's what's telling us to do that. Now, when you're solving absolute value equations, you drop your absolute value. So 500 minus 4x over negative 4x, you set it equal to positive the other side, and you drop your absolute value, and you set it equal to negative the other side. Now in this one, I'll multiply both sides by negative 4x, and we get 500 minus 4x is equal to negative 4x. Bring this negative 4x to the right side, and we get 500 is equal to negative 4x plus 4x, which gives us 500 is equal to 0. Since our x disappeared, we don't use that one at all. Now we'll do the same thing on this other one. Multiply both sides by negative 4x. So we got 500 minus 4x is equal to negative 1 times negative 4x gives us a positive 4x. Take this negative 4x, move it to the right side, and it becomes a positive 4x. So we got 500 is equal to 8x. And divide both sides by 8. So 500 divided by 8. And what's that give us? 62.5. Does decimals make sense? Probably depends upon your application. If you're making something like individual units, probably doesn't make sense. But if you're selling gallons of whatever, then it probably does make sense. At an earlier problem I did today, I didn't round. I took it to 1 decimal place. Well, I did round, but I took it to 1 decimal place. And originally I had rounded, and it was interesting the difference between them. Okay, so this is going to be our critical value. So I'm going to have x is equal to 62.5, and our formula says that it's elastic when this is true and inelastic when this is true, and then it's of unit elasticity when it's equal to 1. So that's our breakover point. Probably doesn't make any sense to choose negative values. And over here is positive infinity, though that doesn't make any sense. And we want to choose test cases. So I want to choose something between 0 and 62.5, like 1. Now I want to choose something greater than 62.5, like 100. Now we want to plug those in to the absolute value of eta, which is the absolute value of 500 minus 4x all over negative 4x. Okay, so I'm going to have 500 minus 4 times 1 over negative 4 times 1. So we got the absolute value. 500 minus 4 is 496. That's negative 4. Look what we're looking to see if it's greater than 1 or less than 1. Now, I don't know what this is going to give us exactly. I know it's greater than 1. So this is greater than 1, so that's all we have to determine. And if it's greater than 1, this tells us it's elastic. Over here, if I put 100 in, I'm going to have the absolute value of 500 minus 4 times 100 over negative 4 times 100. Again, we're plugging that into the absolute value of eta. 4 times 100 is 400. 500 minus 400 is 100. So we've got the absolute value of 100 over negative 400, which gives us negative 1/4. And absolute value of negative 1/4 is a positive 1/4, which is less than 1. So this is less than 1, which means this interval is inelastic. Okay, so just talking about our intervals of elasticity, it's elastic when x is less than 62.5, or it could round out to 63, depending upon your application. And it's inelastic when x is greater than 62.5. So those are our intervals. Okay, now specifically, they're asking us what is happening when x is equal to 40. So we're going to plug 40 in for the x. And that'll give us eta. So we're going to have 500 minus 4 times 40 over negative 4 times 40. 4 times 40 is 160. Too early. Let me write it out, and then I'll do it in the next step. And that gives me negative 160. What was that? 340 over negative 160. And I'll be lazy here. Okay. So 340 divided by negative 160 gives us negative 2.125. Now that's eta. And then if I took the absolute value of it, I'd have a positive 2.125. Now again, do you round it? Do you not round it? Probably depends upon your application. Now if I look over here, the x equals 62.5 was kind of our turning point, and x is equal to 40 would be between 0 and 62.5. So I know it's over here. And even more than that, when I found the absolute value of eta, see how we came up with this, which is greater than 1. So it is elastic. And those are all the different pieces. They're asking if it's elastic, inelastic, and so forth. And they asked us to find the price elasticity of demand. So